Hi everyone, welcome back to another session. So far we've covered a lot, huh? Tell me about it. So we'll talk about all that core concept, but I'm not really know like cover as much as I thought. I'm just gonna cover what I know will be needed since we are going to PCI DSS training. But this playlist will be a playlist that I'll be uploading, beginner friendly content for anyone who is new, just wanted to learn something. I'm doing this again because I think our next framework I'm going with my student is PCI DSS, and it's important for them to have this background knowledge before we even start PCI DSS, okay? So far, we've talked about routers, we've talked about subnetting, MACs, we've talked about switches and so on, So we have to talk about firewalls. We briefly introduced the firewalls, but we said let's talk about firewalls. What is firewalls? Okay. First, firewall, each time you hear firewall, think of it as a filter, okay? It's filter incoming traffic and outgoing, outbound and inbound. Okay. Incoming, whatever network packets that's coming to your network, the firewall actually filters that. Or you as an employee, are you that high? You feel like the fact that you work with the organization, you feel like you can just transfer or send information like out of your network. You don't do that, okay? Because the firewall actually filters traffic, both incoming traffic and outgoing traffic. And it said based on predefined security rules. I will going to say that. And that reminds me, if you are new, go to a playlist. I think everything's IT related playlist where I did cover I have a video on ports and protocols. It's important for you all to understand that. We're going to introduce some, but I'm not really going to teach it now. That's something that will come later in the future. But we'll start talking about these predefined rules. Definitely, you guys will see it, in subsequent slide while talking about ports and protocols. But what's the purpose of firewall? It says it acts like a barrier or filter between trusted internet networks and untrusted internet networks. Okay. Trusted internal as well as external networks. And this is a good picture as to what a firewall looks like. Do you see? So you have your computer network. This can be your LAN, and then you have the network. It could be, the external one. And now you have a firewall that definitely filter incoming and outgoing traffic. Okay, network packets. For example, they said think of a firewall like a security guard at the entrance of a building, deciding who can enter and who can based on the rules. Maybe, if possible, it's a wedding, okay? If you don't have your invitation, you cannot enter. Okay, so just think of it. That's exactly what a firewall will do based on those defined rules. But talking about firewalls, there are different type of firewalls. I'm still gonna talk really in depth about one, but the other one we'll just talk briefly because the goal again is to introduce this concept and hopefully people can go and read about it. If you want to broaden your knowledge or deepen your knowledge as far as firewalls are concerned. So once we introduce this concept, you can also take some time, conduct some research to understand them better. But the very first type has to do with packet filtering firewall. I would say that this is the most basic type of firewall that filters traffic based on predefined rules. Okay. And up now, we're not talking about predefined rules such as the source IP address, that's the sender IP address. As of now, we already know what an IP address is, right? And that's why we spend some time going through that because we know that we're going to be using this word. Now that we are talking about IP addresses, we really understand what it meant already, right? So at this point, the firewall use, filter traffic based on predefined rules, such as the source or sender IP address, the destination or the receiver or recipient IP address, the protocol or the port number. And a typical example of a protocol, I see HTTPS or HTTP. We are going to a website or to our website unlimitedst.com. When you go there, you will see that is a site is secure. We are using the protocol HTTPS, but what's the default port? And that's why you see because we already have this predefined rule, then The network guys and the admin sit at admin, they'll go to the server, they'll be able to pull those, okay? But how does it work? First, it said it checks packets against a set of rules and allows or block them based on the match. What are some of the limitations? Doesn't expect the packet content equals what? A check packet against the set of rules that we mentioned allows or block based on the match. So based on the that basic rules, the predefined rules, of course, that's just what this package featuring firewall would do. But of course, it don't have some limitation. It doesn't expect the packet content or the payload. So if you just have to do that role and that's it, then of course, it's not something that I'll advise anyone to go with, right? And that's why I said it's vulnerable to IP spoofing or attacks based on exploiting weaknesses in allowed protocols, right? So you see, and by now you guys know, right? Like someone can spoof that IP address and they can play around with it. Okay. Say, for example, a packet featuring firewall will allow HTTP traffic protocol, but FTP traffic, but block FTP port 421. So why would they allow this one and why would they block this one? That's something you all can do some research. And this is a typical example. Say organizations already have this rule, allow HTTP traffic for 80, block FTP traffic based on these predefined rules that the organization have put configure. That's exactly what the firewall would do, but it doesn't inspect the package already or the content or the payload, right? And that's why, because we have put this rule that allow any connection or packet coming from this particular port and protocol, which has a default port of 80. As we said that, of course, any packets coming from there is going to pass through because we already have that rule in place. But because we also make a statement, put that rule that you know what, but anything coming from FTP, file transfer protocol with a default port of 21, make sure you block it, right? And that's why we said that again, it has this different limitation. The next one has to do with stateful inspection firewall. We'll spend some time discussing stateful inspection firewall because intentionally I mentioned something about switches when switch will have to float. Remember, I think it was the methodology of the function. When a switch doesn't have a specific MAC address or all the devices connected to a port and the LAN, the local area network, the switch will have to float it. Then while it wait for a response, why for a hub, we said the hub is just going to broadcast it, right? The hub doesn't know how to keep secret, but the switch or switches are very efficient. And we will discuss that in depth here. That way you guys can see, okay? Unlike packet featuring firewalls, stateful inspection firewalls keep track of the state of active connections. You get? It keeps track of the state of active connection, not just predefined rules. It considers the context of traffic by maintaining a state table of ongoing connections. So we made mention of state table. We're going to discuss it shortly. Let's just keep going. But how does it work? First, it will inspect the entire packet. You get? Remember that for application featuring, it does not. It's just based on the predefined, but this one will have to inspect the entire packet. Yeah, so it inspects the entire packet, comparing it to a state table and context of the connection decide whether to allow or block. So this is performing a lot of like an in-depth job. Okay, we're going to see that shortly. And what are some of the advantages? First is that more secure than packet featuring because it understands the context of the traffic. It also tracks and monitors the session throughout its life cycle. And we're going to discuss sessions as we will see that shortly. So, for example, say if you initiate an outbound, remember outbound, you are inside, outbound, incoming, inbound, anything coming into your network. But if you are going out of your network, out of your, like now, I'm home, any connection I'm making, I'm going outbound, outbound, outgoing, right? But anything coming in is inbound, incoming. And that's why they say if you initiate an outbound request to a web server, we're going to discuss web server tools shortly, the firewall will allow the response traffic from the web server back. The firewall will allow the response traffic from the web server back in because it matches the state of your request. And we're going to see that how it really happens. That's the concept of a three-way handshake. First, but what is a state table? They said that it's also known as a connection table. It's an integral part of state inspect for firewall. It is a dynamic database that tracks the state of the active connections passing through the firewall. This table helps the firewall to understand the context of the traffic it's handling and make decisions based on the state of the connections. So this is what we've been talking about. How does state table do it? First, it will store information about the connection state, right? Such as the source, the destination IP addresses, the ports, the protocol, and most importantly, also, not really most important, but also the current state of the communication at any given point in time when that session is being initiated. We're going to see that shortly. If I'm going through a website, how I am connected, communication, doing everything, it definitely tracks that, right? It monitors that, and that's exactly what we are saying when they said that it was the word about a connection, la la la, at the current state of the communication. For example, you have seen, you have established or seen acknowledgement, and then you have the final acknowledgement or finish. And we're going to see that, okay, how it plays. That's a principle of three-way handshake. And that's exactly this will finalize the explanation of a switch flooding the devices that if it doesn't have that particular device a MAC address. So when a packet enters the firewall, okay, the firewall checks if it belongs to an existing connection by looking it up in the state table. Do you see? And then if the connection is valid, the packet is part of that session. The firewall allows it to pass. You have to first check if it's part of that, an existing connection. But if the packet is from an unknown or unauthorized connection, guess what? The firewall would block it. But let's try to understand this, how it works, how it really works in real life. For example, says that when a new request is made, say I want to go to Facebook, I want to visit a website. That's a connection. I'm trying to initiate a session. At that point, we don't have any session going on. But if your user is trying to make that request, first, what the firewall does here is that it creates an entry in the state table with all relevant connection data. First, if I'm trying to go, remember what we've said, if it's a router or the NAT that have to translate my private IP, to how they call to a public IP, depending on where I'm going, it definitely have all that information. And that's why it tells us that this firewall will store the source IP address, the destination IP address, because it already knows where I'm going, right? The router must have already know where I'm going. Like, of course, it already get that destination IP address also. It will store the ports as well as the protocol. It will have that on the state table. And then now we'll go to tracking the section. As data packets flow through the firewall, it continually checks the state table to determine if the packet is still part of an existing valid session. And we're going to see that how it's being created. And then what of the connection termination? Once the session ends, after the communication is completed, the entry in the state table is removed. So that session has ended. If I want to visit a website, as soon as I initiate www.ust.com or whatever, this particular firewall will save my information. It will save the protocol. It will save the port. It will save that is the sender, how they call IP address, and then as well as the destination. And if that session maybe successfully, I have a session going on, I'm browsing the UST website, I'm doing whatever thing I'm doing, it keep checking, check on the state table. But when I am out of that website, I've exited, that session has ended. And once it has ended, guess what? You're not going to keep it. The firewall is not going to keep that session on its state table. And that's why it says that it's going to remove it. This is a typical example of what we're saying. If you look at it, we have the source IP address, we have the source port, we have the destination IP addresses as well as their port. And guess what? We have a different form of communication, port and protocol. And I'll advise you to go to our YouTube channel. Make sure you watch videos on port and protocol. If I have some time, I'm going to create video of all the different ports and protocol and give their functionality and which one is in charge in what. But that's something you guys can do some research just to check. And do you even see the state of the connection? For example, we're going to go there shortly, so don't even bother about this. But you see how long this person was there? It was for 10 seconds, 30, 300 seconds, 60 seconds. So depending on the duration, but once that connection ends, then this particular state firewall is going to remove that session from the state table. Okay, so what have we been saying in a nutshell? If you look here, sync send, or sync send, right? Or acknowledgement, you are sending something. So sync, you are sending. First, what it does, I'm the user. I want to connect to Facebook. I want to connect to my organization website. I want to go to any website. The very first thing is that the connection is being established. So I'm the client. The client has sent a sync request to the server. You are requesting that server, telling that server, hey, I want to visit you. I'm coming, oh, please, I need to visit you. Okay, I want to come to your website. I want to read something on your website. The fact that it happens within seconds, this is exactly, what happened behind the scene. So when I said I want to visit your website, guess what? That server, based on all what, the router and all these other network devices that we have mentioned, at this point, what it's going to do is it's going to receive my request and look at it. No, and then it will respond. When it responds, they are talking of establishment, or the word is even acknowledgement, right? So when you send that send to the server will have to respond like, okay, establish, or yes, I am acknowledging you. I have seen your request. Come. Can you open your door? I was like, okay, wait a minute. I'm coming. You know what? I give you that. I open. Maybe the door is just open. I told you it is open. What are you gonna do? You need to open and get in, right? That's exactly what we are talking about. So when we send it, that server will say that, you know what, I have acknowledged your request. Yes, I know you want to come visit me. I've acknowledged your request. And that's why they said that the session is active and data is being exchanged. And I'll take this time just to explain some form of attacks that usually happens. I guess you must have heard of denial of service, DDoS, distributed denial of service. This is exactly what happened. So many times when they are doing that for a distributed denial of service where, they are targeting so many devices, or denial of service, you can target just one is to many, or one is to one. So when each time when you are sending that request, when this server is say yes, hey, I am acknowledging coming, guess what? Resources are being used. So each time that request is made, resources are being used. So the way DDoS or DDoS or DDoS actually happen is that they can flood that particular server. You can even use so many server, like many is to one. You send that request, send that request, send that request. And each time you are sending the request, the server keep holding a session. It keep holding a session. When the server is requesting, yes, I've acknowledged your request. I've acknowledged. Remember, at this point, maybe we have like 3 or 4, or say 10 session targeting that particular server. We send all the requests. The server will respond to all of us and say that, yes, I have acknowledged it. right? When the server said that acknowledge it, in the course of doing so, the server is also holding out resources. And due to resource exaltation, then you had the word deny of service, such that even authorized users will not be able to log in. It kind of exhausts the server, and that's why you had the word deny of service at a basic level, right? But that's something you guys can read more. If time permits in the future, I'll definitely be happy to create good videos. That way you guys can see how it happened in real life. Then once the server send that, like, yes, I'm acknowledging your request, so it's left on me, right? So what, okay, for that deduct, so when the server said I'm acknowledging your request, guess what? These people can refuse, they don't like acknowledge it. I don't acknowledge it, the server keep holding that resources, and then you have the authorized user who have access to that system, won't be able to log in. And that's why you have the finish with or the scene acknowledgement. So when the server said that, yes, I'm acknowledging your request, then we'll be able to finally, accept it. We are acknowledging scene acknowledgement or finish with. So when we do that, the session is in the process, is being closed. But at this point now, a session is going on, okay? So this is just exactly what we have been explaining here. And it says, what is a three-way handshake? This is exactly what I have explained already. A process used by the TCP, that's Transmission Control Protocol. And that's why I say it's important for you guys to learn protocol and port. Just know, even like the main protocol and port, what they do is important, because for us to even start talking of the OSI model, then we need to understand protocols and port bearer, okay, ports. So this is used to establish, you see, a reliable connection between two devices, as we have just mentioned about the client as well as the server, right? It ensures that both devices are synchronized and ready to communicate before an actual data exchange, you see, begins. Because at this point, data have not been exchanged. We are still trying to create a connection. I mean, a session. We want to establish that session. And that's when we are sending the request, it has to acknowledge, and we acknowledge, and then we have to give back the final acknowledgement. Then that session is being created. Okay. And to talk now about switches here before we continue. So you see, when the switch receive that information, when it send it, it have to, like, tell everybody, hey, I've received this information, but I don't have this person MAC address. Who MAC address? I'm looking for the person, So the switch now is the one sending. When the switch send it, right? Once somebody respond, because you have to send it, say you have 5 laptops connected. When the switch send it, like the first laptop say, okay, oh, this is my MAC address. Guess what? It's gonna acknowledge it. So when you are acknowledging, guess what? Then when the switch look it, okay, then it will release that information. That's why I say it flowed. It doesn't mean that. That's why I say it flowed and it wait for a response. But if there's no response, then it's not gonna release the information. Okay. So the three-way handshake process is used by TCP. We already talked on that. Do you see, when I'm sending, because everybody has to wait. When I first of all send, I'm waiting for you to tell me, right? And then when me too, I'm sending to you. When you send to me, you are waiting. When I respond, I am waiting. Then you need to finish this process. And that's why they call it a three-way handshake. And we literally covered everything. For example, a device A is knocking on the door to initiate the conversation. So we can go there. Do you see? Device A send it to device B. This is exactly what we've explained already. What happened? Device B received a sync message and respond with a sync acknowledgement message. The sync acknowledgement message that device B is ready to communicate, and also send a sync to initiate the connection back to device A. Device B respond by saying, I'm ready to talk now. Let your turn start. Now it's your turn to start. It's just like when I say I open the door. Do you see? It's got example have to do with Facebook, So once that has been sent, then the Facebook now is responding that, if that's the same thing that happened when we all go to Facebook and Instagram. That's the truth. Okay. It will respond that, this is a sync acknowledgement, and then of course the device now will give the final acknowledgement, and a session is being created. And this literally explains everything that we have been talking about. For example, device A received a sync acknowledgement message and sent back an acknowledgement message to device B. This confirms that both devices are synchronized and the connection is established. And we'll see that's what we just discussed. Now once you send the sync acknowledgement, then the device A finite and the final acknowledgement, and that's why connection has been established. There's that session that has been established, then you can do whatever thing you want to do, right? And then, but just to briefly talk about the benefits of the three-way handshake, we talk about reliability in that it ensures both devices are synchronized before any data is sent. You understand? There has to be that connection. You don't just send data like that, which will prevent packet loss or corruption. And then also confirm that both devices are actively listening and ready for data exchange. Yeah, they are listening. So each time you're doing, somebody comes to your house, you definitely have to listen, like, hey, the door is open. Oh, come on in. Okay. And I just talk about Facebook, we covered this already. It's just same principle and everything that, you guys tell me I just like to put so much stuff. We covered that already. And then we'll see, okay, so let's talk about the state table update. So say first, as the handshake progresses, the firewall update the state table with information such as, remember at this point, we'll first of all talk about this, the fact that it checked the whole packets, have the source IP, the destination IP port protocol, as well as the connection. And that's why we said that once as we are progressing towards this handshake, this firewall in particular, the state firewall also update its state table with information such as the source IP address, the destination IP address, the port numbers, and the state of the connection. Do you see? The state of the connection, and that way we said that when that connection ends, then it remove it from its state table, right? So before the handshake, the firewall has no knowledge of the connection and will initially block unsolicited packets. Do you see? Have you received unsolicited email? Do you have all the spam folks just calling you? I just press, voicemail. Keep it there, okay? But if that session has been established during the handshake, the firewall tracks the progress of the handshake, allowing valid packets. Do you understand? First, it will allow valid packets from sync to sync acknowledgement and finally to acknowledgement to pass through and updating the state table with the connection data. So it definitely updates each and every let's say transaction or session per se. After the handshake, once a connection is established, the firewall continue to track the session state, right? Allow the data to flow based on the established connection. Isn't this thing too sweet, right? And it said that packet fitting based state. So after the connection is established, the firewall ensure that only packets related to that specific connection, you see, specific are allowed. For example, if a connection was established via a three-way handshake on port 80, HTTP, the firewall will only allow packets related to, you see, packet related to that connection to pass through, that is traffic on point 80 from the same source and destination IP. It will not allow some form of information from that same source coming from different IPs or different ports or protocols, right? So what's important of the state table is that it maintains the firewall can ensure that only valid expected packets are allowed. This helps prevent attacks such as spoofing, where attackers may try to impersonate legitimate user, right? Or the next one has to do with efficiency, in that it allows the firewall to process packets faster since it doesn't need to check every packet in isolation. So it simply refers to the state table to verify the packet's legitimacy, right? And this is an example of what we've discussed so far. So if you see the state table, it tells you the connection is established, is allowed, and the connection is closed. And each time it's closed, then it will remove it from the state table. Okay, the next one is proxy firewalls. What are proxy firewalls? It says that this firewall is a type of firewall that sits between proxy. By now, we all know what that thing is. Internal network, that's your organization network. And each time we start to learn, now we understand that better, right? External networks, such as the internet, it acts as the intermediary that handles requests from client on the internal network, forward them to external resources, and then relay the responses back to the clients, right? These additional layers control provide better security compared to traditional packet filtering firewalls, okay? So let's explore why this is beneficial. First, it says client make a request. So when a client, say a user computer within your organization, inside your internal network, you want to access an external resources such as a website, okay? We said we can just go, maybe you are working, you want to access UAT website. What happened? So instead of sending the request directly to that external website, because you are in there, we can't just be accessing stuff like that. So instead of you having direct access, your information, everything, though you have NAT, all those things that will translate your IP addresses, but you are actually coming from a LAN, from an internal network. So instead of that request to be sent directly to that website, the request was first be sent. You see, instead of sending the request directly to the external server, like the web server, we're going to discuss about web server, the request goes to the Proxy firewall, right? So the Proxy firewall inspect the request to ensure it's legitimate. First, to make sure it's legitimate according to the predefined security rules. So depending on the rules that they have, it's going to first check, right, if it's legitimate, though you are the one trying to go from outside, okay? Trying to go out there. First, it checks for things like the type of application, the destination address, or the type of content being requested. It checks that because I've worked organization where they do content filtering. If you try, it's blocked. You cannot access it. I work organization where I couldn't even access Google. I cannot. I cannot. Yeah, it was blocked. Okay. So the proxy firewall can also perform deeper inspection, like checking even the URL, right? Analyzing even the headers and scanning for malware in the requested content. So do you see how powerful this one also is? Right? So say if the request is valid, the proxy firewall forward it to the external server on behalf of the client. So if first of all check out all of those, if something didn't make sense, it's just gonna block it. You're not even gonna go there. But if it checks and everything looks valid, then it will definitely process that, right? And that's why I say it will forward it to the external server on behalf of the client. The external server sees the firewall as the originator of the request, not the internal client. Do you see? It's all security, guys. And it's important for us to be understanding some of these things. It's so sweet, right? So it will not, like, that this thing is coming from this proxy, but guess what? So what if now in the three-way handshake, the external or web server replies? If it reply, guess what? Is it going to go directly to that person? Not necessarily. It will also go back to the proxy. The proxy will also check before relating back to the client, right? And that's why they said that the external resources send a response to the proxy firewall. But what would the proxy firewall do? The proxy firewall inspects the response for any potentially harm content before forwarding it to the requesting client. And of course, the client received a response from the external resources, unaware that the proxy firewall has been intermediary, right? Featuring and protecting them from direct exposure. But all of this is happening. Nobody knows. Server does not know. External web server does not know. Client doesn't know. But this has been configured within an organization architectural network such that they can better protect their assets. And this gives us an equal view of all what we'll be discussing. We talk of packet filtering. You see, just based on the rules, the predefined rules that organization have in place, it will either allow or it will block. While we talk of stateful firewall, where you have a state table, and with that state table again, right, it does a full analysis of that content, check the source IP addresses, source and destination IP addresses, port protocols, and even the state of the connection be in sync, sent or sync and sync acknowledgement, as well as acknowledgement. While for proxy, if you see the if you see the how they call the request tool or the client request, it first of all go through the proxy server before even accessing the internet. And once you go to the internet, still it has to pass through the proxy server before even relaying that information to the client or the user, right? Another one that we're going to talk has to do with next generation firewall. We really wouldn't talk much. I just try to touch base on some of this. That way you guys can have some background. But again, as I said, just wanted to expose this to you all. So make sure you have to take some time to conduct your research to better understand some of these, okay? So next generation firewalls are advanced firewall that offer all the features of traditional firewall, but include additional capabilities such as deep packet inspection, as well. It includes other capabilities such as deep packet inspection, DPI, intrusion detection, as well as application awareness and more. So we're going to see about IDS as well as IPS. But how does it work? This one, it combines traditional firewall featuring like the predefined rules I've mentioned, and also feature like deep packet inspection, such as you see LSS decryption, intrusion prevention, identity-based filtering, allowing them to block more sophisticated threats. But what are some of the advantages? Block advanced threats such as zero-day attacks and malware, right? It provides visibility and control over application, not just port and protocol. So even extend to layer 7 of the OSI module. As I said, I can't wait to teach, OSI module. For example, the next generation firewall can block an application, you see, like WhatsApp, while align extension services like email, based on application level filtering. And that's why I said that this, call it a next application firewall. And this is a perfect example of what we have been discussing so far. Right? And then quickly touch base on a secure level gateway firewall. So this operates at a session layer and monitor TCP handshake to determine if a session is legitimate. And that's why it's important, because we need to have this background from layer 1, layer 2, layer 3, at what stage, which stage on the OSM model you need to have your router, your switches, and our connection. We need to understand all of this. And that's why at the basic level, I'm glad that we're able to cover those at the beginning of our training. So now we are talking about session, we really understand what it's all about, right? But with this, it tracks the initiation of connections to ensure that valid solutions are established, right? And it doesn't inspect the content. So this one has to do more about a connection or session. And for now, you guys know how session, it's been generated or been initiated, right? And it doesn't inspect the content of the traffic once a session is established. Do you see that? So first, this is lightweight compared to other firewall because it doesn't inspect the entire content of the packet. Good for protecting against certain type of network attacks. When a user requests to access a remote server, the secure level gateway ensures that the connection is legitimate, but does not inspect the data exchange once the session is set up. Once that session is set up, that's my main business. I don't care how you guys do it, how you gonna do it, that's your business. I'm just concerned about how I want to make sure this session is initiated, okay? And that's exactly what this thing does. And if we can look at it right here, it says that do you see? So at this point, we have the firewall. We'll go through the sync, we'll go to the sync acknowledgement, and finally to the acknowledgement. That session has been initiated, is created. Okay, good and fine. My business is over. Okay. I don't care about whatever data package that you guys communication how is going. I am concerned about the initiation, to make sure a session gets initiated or created. And then the other one that we're going to talk on has to do with software firewall. I would say software firewall is also a program that runs on general purpose computer or server to filter traffic and control network, but it works similarly to a hardware firewall in that this one is installed on individual devices like your desktop, your laptops or your server. So like all those devices that we mentioned, so individually installed on those devices. I would say, for example, it's easier to deploy and configure on individual laptops or devices, ideal for home or small office environment. For example, a software firewall on the laptop can block incoming connection attempts, such as preventing an unauthorized or untrusted website from accessing your computers. And you see it, so this is something that they can just exploit or deploy it. Is it deployed, installed on all the devices? So based on that rule, what you want to allow, what you want to do. See, for example, web server, outgoing, of course, allowed, email client, outgoing allowed, but incoming remote desktop denied, file sharing, incoming denied, so UDP and all the different protocol that we have. But this is just to show us an example of what is allowed and what is being denied based on the rules that they've installed on each and every devices. And the last type of firewall we're going to touch briefly has to do with hardware firewall, which says that it's a physical device that sits between the network and the internet, where it filters traffic to prevent unauthorized access. But how does it work? It operates independently on individual devices and installed at perimeter of the network that monitors and filters in and outgoing traffic. So what's the advantage? Provide robust network security for organization and can be deployed at the network perimeter for advanced security. For example, a hardware firewall is commonly used in business to protect their internal network from threats on the public internet. And this gives us a perfect example. Do you see the firewall? You see our internal network, you have it at the perimeter and everything is being protected. You see those network packets that are being allowed, and then we have those that are being blocked. Then one of the things that we're going to talk about, firewall rules and policy. I just gave us an overview of this. Security-wise, depending on what the organization goes with, they put it on their policy. Again, we'll have to start talking about the different rules and, port protocol and what is allowed, what is not allowed. So this is why I expect any security person to also pay attention. Right, first, you're going to be hearing of access control lists. Accessing control, there are times that I'm going to request artifact like access control list. Wait, says, access control list says, give me the list that tells you the kind of access that have been allowed or denied in your environment. And that's exactly what the thing is, ACL, okay? So it talks of rules that tell the firewall what traffic to allow or block. Yeah, and that's why, for example, allow HTTP port that block all inbound from this particular IP. So that's, you just have that list says what are you the different maybe what advice, how can I say? So that just tell me about the access, the level of access, what you want to get into your network, or denied or refused or blocked. So produce me that list. And there are times that you'll be accessing controls. This is something you're going to be asking, right? So think of access ACL like house rules. Visitor can enter through the front door, but delivery trucks should be used by the back door. Do you see? So again, you have the different type of access, what is allowed and what you want to block, right? And this gives us a perfect example of what we've been discussing. For example, we said that allow TCP traffic from any source with IP and destination port of 80, but for TCP transfer or traffic from source IP with destination port 443, okay, allow this is being allowed. But if we want to talk about Telnet, block TCP traffic from any source IP address port 23, or likewise block TCP traffic from any source with IP address port 445. Once we put this these rules, then it already knows, right? It knows what to allow and what not to allow. And when you also ask for the configuration setting, you will see this, they already have it there, right? And those are some of the artifacts that we're going to be requesting. So it's important for us to know, and I will still repeat, take some time to learn some of these basic protocols and port just to know how they work, right? And exactly this is what we've talked. We just, you see, I just write it to example for us to see. And this also shows, do you see? Yeah, so you see the firewall, what it does allow, what is a block, likewise also there. And then talking of firewall configuration, say for example, blocking unwanted traffic from a suspicious source, IP source. Say, for example, a company uses a stateful inspection firewall to block all traffic from this IP while allowing all other traffic. Once you use that way, block all traffic coming from this IP. Remember now this IP can be that range, right? Or maybe a particular way you want to specify the host, or you want to do like remote the host network. But how you define that thing, it will definitely block it. Okay. And you see, this gives us like a configuration setting. For example, firewall enable action. Do you see source? It says, you know what, drop all of this. Inbuilt, drop any connection coming from these sources, right? And likewise, okay, statute enable. You see, you can either say block or whatever web page that they're gonna use, the firewall definitely knows. But why firewalls are crucial for security? Because of you protect from unauthorized access, firewall block harmful traffic, reducing the risk of attacks, preventing malware spread, desktop malware from spreading across the network. And now, when I keep telling people that cybersecurity is a big word of IT, some people say, no, I'm wrong. It doesn't matter what you do in IT, cybersecurity supervises everything. And all of these things that we have been discussing, they have to document it on their policies. And security manage and keep maintain those policies. And everything that we're going to be discussing, how do you even know what organization have in place? You're going to read everything from their policy. Their policy will tell you they are doing this, and because of their policy, you will definitely use that policy to assess the different controls. And as I said, this comes heavily on PCI DSS, especially when we start to scoping, determining what is involved, what's not involved. That's why it's important for you all to understand this concept better. And if you look at it very well, do you see, you always have these folks doing some terrible stuff, right? Firewall, you see network without a firewall. Do you see? Without a firewall, definitely somebody can be right there, right? But when you have firewall, it definitely protect not only firewall, but other networking, that was mentioned, that will put again defense in there, put all of this to better protect organization assets. But there are also times where they might also have misconfiguration. And that's why it's important security. We're going to be assessing those because, yes, they are humans. People can make mistakes, right? And that's why I say align all traffic. This defeat the purpose of a firewall, right? Weak ACL rule, too broad of rules can expose the network to threats. And then, for example, visualize a simple error scenario where firewall mistakenly allow all inbound traffic. Just imagine inbound, you allow everything. Goodness God, yeah. So if a firewall is configured to allow any IP addresses from outside, it is leaving doors to your house. It's just like you leave your door unlocked as well. So imagine, do you see free entry? Anybody can just get in and out as they would like, right? So that brought us to the end of firewalls, and we've also discussed now IDS and IPS that we briefly talk about, and then we'll discuss on all the different server types, and you guys will see why these concepts are really important as far as PCI DSS is concerned.